Hi students, let's look at this concept here, which is the area bounded by two curves. So there are two types of questions they could ask you. One is projected to the x-axis and the other one is to project to the y-axis. Typically the one with projection to the x-axis will be easier. Will be the one projected to the y-axis will be easier because in the syllabus we do not have many difficult expression for this kind of question, right? So let's look at this part here. And the first thing that you must understand is that the area bounded by two curve, say if you want to find this area here, right? So here, bounded by two curve, y equals to fx and y equals to gx. The first thing is you must identify which area is on top, which equation would be on top. So for example, this case, let's say this is y equals to fx. And this is y equals to gx, right? So if you want to find the area bounded by these two curves here, you have this is A and this is B here. What we really need to do is actually take the top curve. This is a top curve here, minus off the bottom curve, okay? So all this jargon here, what you need to know is just taking the top curve minus off the bottom curve, all right? It just means that fx has to be on top of gx. So this area here, say this area will just be AB taking the top, which is fx, minus off the bottom, which is gx. And this will just give us dx here, okay? So that's the idea there. So this is how you get the area between the two curves. Now take note that the two curves, there won't be any negative area because what happened here is essentially it will take care by itself. We're actually finding the difference between the two curves. So if you think about it, this is actually a positive area. If you integrate this curve here, we'll give you a positive area. Let's say this region here, this will give you a negative area. But if you take positive area minus off a negative area, okay, it will automatically add up the both area up. Similarly with this part here, if you have a negative area here and this is as well a negative area, so you take the first area here, which is negative, right, negative area, minus off the second area here, which is also negative, projected towards the x-axis, it will automatically settle itself. So you don't have to worry about negative area or positive area. Just make sure that you know that if it's two curve bounded, you will definitely find the area between them. Alright, so let's look at the second one here. So I'm just going to quickly label the red one as y equals fx here. And this is y equals to gx. Okay, similarly, there are three areas bounded here. The first area here, and second area here, and the third area here. Okay. Now what you need to know is this. I'm going to let this be bounded by, let's say this is M, P, Q, R. Okay, P, Q, R, and S. Okay, this area here, let me just use A1, A2, and A3. A1 here, the area number 1, will be P to Q. Take the top curve. Top curve would be this area. This one here, top curve, minus off the bottom curve, which is fx here. Okay, dx. So if you want, you could just write this as y1 and y2. So this will just be p to q. G is y1, so y1 minus y2 dx. Okay, this will be easier to understand here. After which area 2, similarly, if you think about it, you always take the top curve. So top curve is y2, right? If you trace down is y2, so it's actually from Q to R. So we're going to take the top curve minus the bottom curve, which is gx here. So this case will be QR y2 minus y1 dx. Okay, just make sure you understand that the top curve for A2 is the red color one instead of the blue color one. Alright, so fx minus gx, so it's y2 minus y1. Then after which we have A3 here. A3 will just be from R to S. R to S will just be the same thing. Similarly, this is y1, which is gx minus fx. And this will just be rs gx is actually y1 minus y2 dx. Okay, so that's how you understand the area between two curves projected to the x-axis. If we're going to look at projection to the y-axis, it's similar. What we need to know now is essentially this area here. Typically for y-axis in our syllabus, it won't be so too difficult, but I'll just go through it very quickly. So you can see that as you project, the area between here is no longer projected to the x-axis, because now the boundaries are like they are horizontally projected, right? So this case here is actually the y-axis here, which is like playing a part. You can see that it's actually projected towards the y-axis here, the boundary here. Okay, so you take this trapezium minus of this area in between here. This will be A and B. So if this happens to be x1 and this is x1 equals to g y1, and this is x2 minus g y2. What we need is this area here. Same thing, top minus bottom. In this case, the top would be this is the top direction. If you think from the perspective of x-axis, this would be the top direction. If x-axis is the y-axis, so the top would be this curve here. All right, for the y-axis. So just remember that. Then this will just be from A to B. The top will be x1, so it's just gy1 minus gf gy1 and f. Okay, this is f, then f y2 dy, and this will just be a b x1 minus x2 dy. All right, so similarly, if we are going to look at this as x1 equals to g y1, this is x2 equals to f y2, this area bounded by it doesn't matter. Let's say this is P and this is Q, this boundary here. It doesn't matter the negative region. When you take two curves, the difference between them will just be the area between them. Alright, so this case here will just be PQ. We take the top curve, which is x1, which is G y1 minus Fy2 dy. Okay, so this will just be PQ x1 minus x2 dy. So we're going to use this concept here and see how we can use this formula here for our subsequent part. Okay, so any question, please let me know, and I will see you in the next question.